In order to demonstrate how we can apply SRL to mathematical problem solving, I'm going to walk through an actual math word problem, focusing on the first stage of the process, understanding the problem and determining your goal. The first thing we want to do is we want to read through this problem. Now, I don't care about the details on the first read. I don't care about the numbers and the fancy math words. All I care about is the general idea. I want to start forming a picture in my mind of what's happening. So we can read through. The foot of an extension ladder is some distance from a wall. The height that the ladder reaches on the wall and the length of the ladder are related in some way. How long is the ladder? So what I've achieved by doing that is that I know more or less what this is about. I know it's not cars driving or people making money, it's a ladder. A ladder leaning against a wall, I can picture that in my head. And I know that we're looking for distances. So this helps me a little bit to sort of frame the question and understand where I'm going. Now I want to read through again, and as I read through, I want to start pulling out the important relevant information. This time I'm not going to skip over the numbers. So we'll start with the first sentence. The foot of an extension ladder is 9 feet from a wall. I'm going to make a little mark here to show that I've gotten that far. What I want to do is I want to translate this information into something that I can understand, into my own words or my own symbols. So I'm going to start by drawing a picture right away. I'm actually combining step 2 and step 3 here, because this is a very visual problem. So I know that there's a wall. Well, if there's a wall, there's probably a ground as well. Here's my building, there's a wall, and there's a ladder. The foot of the ladder is 9 feet from a wall. Okay, so this distance is 9 feet from the wall to the ladder. And that's this sentence right here summarized on my image. The height that the ladder reaches on the wall. Stop right there. The height that the ladder reaches on the wall. Okay, so obviously this ladder is leaning, as ladders do, against the wall. The height that it reaches on the wall, so that's its height right here, height on the wall, and the length of the ladder. So the height that the ladder reaches on the wall and the length of the ladder, well, that's this right here. We don't know anything about the height and the length yet, but we at least know that they're going to be important. The length of the ladder, that's the actual ladder itself. Alright, what do we know about these? The height that the ladder reaches on the wall and the length of the ladder are consecutive integers. Stop right there. Consecutive integers. So these two things are consecutive integers. I'm going to stop in the question right now and think a bit about what that means. Integers. I know what integers are. Those are numbers like 1, 2, 3, or -1, -2, -3, or 0. I know that consecutive means one after the other. So if two things are consecutive integers, it means they're these kind of numbers that come one after the other. Oh, so for example, 2 and 3, those would be consecutive integers. Now I know that we're talking as well with these about the height of a ladder and the length of a ladder. So I know right away that I can eliminate these kinds of numbers. They're not going to be negative lengths. And it's probably not going to be 0. It could be, but it's probably not. So we're looking at these numbers, 1, 2, 3, 4, the counting numbers, and we want 2 of them that are in a row. So I know that I've processed and interpreted what this means. And the last bit, how long is the ladder? Well, that right there gives itself away immediately as the question. This is our goal. How long is the ladder? So this is where we're aiming to get. So what I've done right now, I haven't done any math yet, I haven't done any calculating. All I've done is get a grasp of the question and what's going on. Now we're ready to move on to stage 2.